Alright, so right now I want to go over slope. Slope is very much related to our previous video, and which was about coordinate geometry, having different points on a coordinate system, like what we had before. We can make different shapes like squares, triangles, and so on. And really what we focused on were making shapes from lines. Lines that we worked on had 2 points. Either we used the distance formula or the Pythagorean theorem to find the distance between those 2 points, but there were 2 points nonetheless. And these lines have slopes. Slopes are the steepness. It's the steepness of the line, okay? So a huge hill could be very steep. A small hill won't be that steep, and it can go in any direction. So let's talk about slope. So in this case, we check what the line is doing from left to right. So from left to right, this line is increasing in y. It's going up, which means that it has a positive slope. It has a steepness that is positive. Think of it as an upward hill. How do you find this steepness or this slope? Well, we represent it by m, and it's rise over run. So you'll hear this over and over again. This just means give me the distance that it rises between any 2 points, and give me the distance that it runs between any 2 points, and divide the two, and that's my slope. So rise, that means give me a difference in y, and then the run is a difference in x. Well, we know the differences in y and x, they correspond to different directions. So a difference in y would be the vertical direction. A difference in x would be the horizontal direction. This looks familiar then, because before we decompose this line into x and y components, horizontal and vertical components. So let's say this point here is 1, 1, and let's say this here is -1, -1. And now we can find out what this point here is, and that point is 1, -1. Alright, so how do we find the slope? The slope is the steepness, so the rise would be the difference in y. So we can represent that by y2 minus y1, and the difference in x is x2 minus x1. We're using the same notation that we had with the distance formula. So let's make this x1, y1. It doesn't matter which point you use first. And this x2, y2. So now what is y2 minus y1? That would be -1 minus 1. So -1 minus 1. And x2 minus x1 is -1 minus 1. Which means that we have -2 over -2, or 1. So our slope is 1. Is 1 positive or negative? It's positive, which makes sense because in the beginning I said it's going upward. So a slope that is greater than 0 is an upward slope, or positive slope. A slope that is less than 0 is a negative or a downward slope. And what if a slope is just 0? If m equals 0, then that's just a horizontal slope, which means you're not rising anywhere. So let's look at a slope that has a slope that's 0. What kind of line would have a slope that's 0? Well, this line, of course. It's not rising, it's just going to the left or to the right. You're basically walking on flat ground. There's no rise, but there's only run. So m equals rise over run. Well, rise is 0, and run is whatever you want it to be. It could be 5, it could be 10, but the point is m would be 0. 0 divided by any number is 0, except 0, of course. You can't divide 0 by 0, which brings me to my next point. You can have an undefined slope, and that undefined slope will be in the case of a vertical line. So here if you have this vertical line, well, is there any run? No, there's no run, but there's only a rise. So that means that m is going to equal some run on 0 run on the bottom and some rise. It could be 5. Well, 5 you can't divide by 0, so this would be undefined slope. So if you ever see a vertical line and they ask you to find the slope, it's undefined. If they give you a horizontal line and they ask you to find the slope, it is just 0. And then the rest are in between, okay? The rest are in between 0 and undefined. You could have a -0.5 slope, 1/2 slope, 10 slope, and so on. So that's how you find slopes, okay? So that's slope, the steepness of a line. Alright, so now let's try a problem. Find the slope between these 2 points, 1, 0, and 10, negative 5, and tell me if it's positive or negative. Okay, so m equals, well, let's label this x1, y1, x2, y2. Well, that's y2 minus y1, which is negative 5 minus 0, over x2 minus x1, which is 10 minus 1. So that is a negative 5 over 9. And that is a negative number, so it's a negative slope. So it's going to look, well, this is not drawn to scale, but it's going to be a line that's going downward from left to right. And now that we know about slope, let's talk about the y-intercept. So I'll write this here, the y-intercept. All of these are lines. We have different properties of lines. We have the distance, we have the slope, now we need the y-intercept. So let me draw another coordinate plane, and here I'll draw a line. So this is my line. Now you see where the line hits the y-axis, that is the y-intercept. It's a point, okay? Or you can think of it as just a y value. Either way, it's going to be where the line hits the y-axis. Here's the y-axis. Where does this red line hit the y-axis? Right here. So let's make up what that point would be. Let's say that's 0, 1. So that point is 0, 1. So the y-intercept here is y equals 1. You can think of the point as just 0, 1, either way. And now let's find the slope of this line. Let's say another point here would be, let's say 1, 3. This is 1, 3. So the slope would be rise over run. So 3 minus 1, which is 2, over 1 minus 0, which is 1, slope of 2. So this has a y-intercept, y-intercept of 1 and a slope of 2. Great. Now what I want to do, and you'll see why, is I want to call y-intercepts not by its name y-intercept, but by a variable. And I want that variable to equal b. So b stands for y-intercept, m stands for slope, as we know. And now we can actually write the equation of a line. A line is a function. So it takes in an x value and gives out an output, which is a y value. And we can write the equation of a line so that if you give it any x value, it'll give you the y value that corresponds to it. In other words, if I told you that x was 1 here, and I plugged that into the input of a line, it would give me 3 as a y value. So y equals f of x, and what does that function equal? Well, in this case, before I show you how to do it, I'll tell you that the equation of the line is going to be 2x plus 1. Okay, let's see if it works first of all. If the equation of a line is 2x plus 1, that means that f of 1 should be, well, that should be 3. Let's see. 2 times 1 plus 1, yes, that equals 3. Now if I plug in 0, we should get 1, because here's 0, we have 1. So 2 times 0 plus 1 equals, yes, it equals 1. Because if we go to the x coordinate of 0, then we have to go up 1 to be on that point on the line. So great, it seems like this line equation works. But how did I get it? How did I go from just knowing 2 points? How did I go from just knowing 2 points to finding the equation of a line? Well, it turns out that all you need is 2 points. So I'll write this here. All you need are 2 points to find the equation of a line, So the form of the equation of a line, the general form would be y equals mx plus b. B is the y-intercept, so y-intercept. M is the slope, and x and y are the two variables. Y is the output, and x is the input. So you can think of y as also f of x if you want to. So great, y equals mx plus b. That has a ring to it, so you need to memorize that. Now let's try and use this again so we get practice with it. Find the equation of a line given that a line has these 2 points. Let's see, 3, 4, and 5, 6. So find the equation of a line given these 2 points. Well, the equation of a line is y equals mx plus b. If we have m and b, then we found it. Let's find m. M is y2 minus y1 over x2 minus x1. We have the 2 points, so we can definitely find that. Very easy to find the slope. This equals 6 minus 4 over 5 minus 3, which is 2 over 2. So that equals 1. So m equals 1. We could just write it here. M equals 1. Okay, so we have the slope. Now I want to find the y-intercept. So the y-intercept, or b, is going to be a quantity that we find once we plug in one of these points in our equation. So right now, what do we have? So right now we have our equation as y equals mx plus b, but m is 1, so we have y equals x plus b. Okay, so using this equation, let's plug in any point, because all of these points, two of these points are on the line. Let's plug in 5, 6. So x is 5, y is 6. So we have 6 equals 5 plus b. And great, now we can just solve for b. So we get, here we get b equals 1. So we have b equals 1. And just like that, we found m and we found b. So again, the rule is for m, use the equation you know, y2 minus y1 over x2 minus x1. For the y-intercept, pick a point that you know is on the line and put it into our equation once you've found the slope. And then you can solve for b very easily. So now that we have now that we have the slope and the y-intercept, we can say our equation is y equals 1x plus 1, or x plus 1. That is our equation. Y equals x plus 1. Great. And so we can graph that if we want to. Let's graph it. So our equation is y equals x plus 1. How do we graph this? Well, this is interesting. We need to look at the coordinates. Oh, this is x and this is y. So where's the y-intercept? It's 1. 1 is here. And so we have 1 here. Now, from this y-intercept, we know what the slope is. The slope is 1. If the slope is 1, that means the rise over run is also equal to 1. Well, we have rise over run equaling to 1, but it seems like 1's only on the numerator, but 1 is the same as 1 over 1, so the rise is 1 and the run is 1. Remember what rise and run means. Rise means to go up or down. If it's negative, you go down. If it's positive, you go up. And run means to go right or left. If it's positive, you go right. If it's negative, you go left. In this case, our rise is 1 and our run is 1. So that means we're going to go up 1 and to the right 1 to make our line. And we keep on using that rule. So up 1 and, well, I'm not going to draw the point there. So but we'll have up 1 and then to the right 1, and that's our new point. Up 1 and then to the right 1, that's our new point. Up 1 and to the right 1, that's our new point. And we can go down 2 to continue the line. Down 1 and to the left 1, down 1 and to the left 1. And hey, look, we have a whole bunch of different points for our line. So this is our line. This line is y equals x plus 1. And that's awesome. We just graphed the line just using the equation, and we found the equation using our techniques to find the slope and the y-intercept. So that is the graph y equals x plus 1. Awesome. Let's try another example of this. So I'm going to give you 2 points, and I'm going to draw it on the coordinate axis this time. And so we have the point 3, 5, and -2, -4. So find the equation of the line, and also, just find the equation of the line, because if you do, you already know you're going to find the slope and the y-intercept. Great, so sort of think of how you would do this. The way I would approach it is first find the slope, then the y-intercept. So I'm going to label these points, x1, y1, x2, y2, and once you do enough of these, it'll become second nature. So given that, I know the slope is y2 minus y1, which is 5 minus -4, which is 9, over x2 minus x1, which is 5. So slope is 9 over 5. Great. Now, how do we find the y-intercept? Well, we know the equation is y equals mx plus b, so we already have the slope, so it's y equals 9 over 5x plus b. But we still need b, which is the y-intercept. So we can plug in any point. Let's pick this point to plug in. So we're going to plug in the y value as -4, the x value as -2. So we have 9 over 5 times -2 plus b. So let's solve for b. We have -4 equals negative 18 over 5 plus b, and b would equal negative 2 over 5. And you can just use your skills of solving for variables in linear equations to find that. So b equals negative 2 over 5. All right, so we have the equation of the line then. We have y equals mx plus b, or y equals 9 over 5x minus 2 over 5. And so 9 over 5 is a positive number, which is why we have a slope that's positive. And here's an interesting point. So we have the equation, but even though the y-intercept is negative 2 over 5, it doesn't look like this line is hitting it there. That's because I drew this line before actually finding the y-intercept, which now we know it's not a good idea because I just drew it from my hand. I just free drew it. So if you free draw a line, you're bound to get something wrong. So the best way of doing this would be to draw the line afterwards. So let's do that now. Now that we have the equation from the 2 points, now we can draw the line. And so we'll get a better and accurate representation. The line is still correct, the equation is still correct, but I just want it to look like what it is. So we start at negative 2 over 5 on the y-axis, so that we can just imagine is there. Okay, so then, and this equals y, so then we have a slope of 9 over 5. So we're going to go up 9 across 5. So up 9 across 5, up 9 across 5, and you see how you can just estimate down 9 across negative 5, and then so on. So our line would look like that. So it's the same thing as what we had before, just shifted a bit down. This is shifted a bit down. But the same points are there. The 1 point would be, what did we have? Negative 2, negative 4. And then another point would be 3 comma 5. Okay, so everything is still the same. We just drew it better. So when they give you 2 points, remember the things to do to find the equation is, number 1, slope. Find the slope. Number 2, find the y-intercept by plugging in a point. So plug in any point. Plug in any point that they give you to find b, which is the y-intercept, and then write out the line, and then after that, what you want to do is just graph. Remember, graph the y-intercept. We did that here. We put that point, and then do the rise over run. Rise over, run some amount, rise, run some amount, and then you can do it down, and then just connect the dots. So it's pretty simple. That's how you find a line given 2 points. And then you can be given some other information that doesn't include 2 points, and you can still find the line. But the most straightforward way is to be given 2 points, and you find the equation of the line that way. All right, great. So now I want to talk about some properties of lines. So we have lines with slopes, okay? Lines with slopes. And now these slopes can be any number. What if we have 2 lines, so line A and line B, but line A has a slope of 2 and line B has a slope of 2. Okay? Does that mean that they're the same line? No, it doesn't, because if they have the same slope, they can be anywhere on the rectangular grid. All it means is that they have the same slope. So I could draw line A like this. All right, that looks a bit squiggly. So I draw a line A like this and label that A, and then I can draw a line B like this. You see, they have the same steepness, the same slope, which is m equals 2, but they're different lines. Why are they different lines? Because they have different y-intercepts. This y-intercept for A is here, this y-intercept is here. So same slope, different y-intercepts. But what do you notice about these 2 lines? Well, they're parallel. What does it mean to be parallel? It means that these lines have the same slope, which in then turn means that they go in the same direction, but never cross. Never cross, they never intersect, they go in the same direction. So they're both going up in the same direction, and they never cross, and likewise they're both going down in the same direction and never cross. So the rule is then, if 2 lines have the same slope, in this case it's m equals 2, the same slope, then they are, and this is important, they are parallel. And we just explained what that definition is. So That's the first part I want to go over. If two lines have the same slope, they are parallel. So let me give you an example with that. Are these two lines parallel that I'm going to draw? I am going to, actually I'll just give you the points. We have line A that has 2 points that are 0, 0 and 1, 1, and line B that has 2 points that are 3, 3 and 2, 2. Okay, let's see. What is the slope of the first line? Well, this is x1, y1, x2, y2, and let's find it. So m equals y2 minus y1, so that's 1 minus 0, and x2 minus x1 is 1 minus 0, so slope of line A is 1. Slope of line 2 would be 2 minus 3 is negative 1, and 2 minus 3 is negative 1, which is 1. Yes, they have the same slope, so they are parallel. And then you can also test if lines are parallel when you're given the line equations itself. So let's give ourselves two line equations. Y equals 2x plus 5 and y equals 2x minus 100. Well, what's the slope of the first line? The slope here is m equals 2. The slope here in the second line is m equals 2. So yes, they are parallel. So that's how you tell by just when you're given the equations of the line, or the lines itself. So we talked about parallel lines, which should be pretty straightforward. All you're looking for is similar slopes or same slopes. But lines are not always parallel. They can be perpendicular as well. And we've seen perpendicular lines before when we talked about the Pythagorean theorem. This is a 90-degree angle. This line A, I'll call, and this line B are perpendicular, meaning that they intersect at a 90-degree angle. So these lines intersect at a 90-degree angle. These lines also intersect at a 90-degree angle. So these are called perpendicular lines. And what you get into higher math, or even maybe now, they'll also be called orthogonal lines. But either way, they both mean they meet at 90 degrees. So you see here, they definitely do not have the same slope because they're intersecting. And we know that they're perpendicular. So what is a relationship between their slopes? Well, let's play around with it. Let's draw two lines that are perpendicular and see what we can conclude from them. So I'm going to give you two lines. The first line will be y is equal to 3x plus 2. And then the second line will be y equals to negative 1/3 x plus 1. Okay, so we can graph them. Now, since I didn't tell you how you can tell if they're perpendicular, you shouldn't believe me when I say this, when I just draw it and it looks perpendicular. You should believe me when I give you proof or give you an equation. So let's just draw it out just so we see it first. So let's see. And you can always derive this later, but it's not that important right now. So 3x plus 2 has a y-intercept of 2. Okay, so if we have a y-intercept of 2, we can write it here as 2. And then it has a rise over run as 3 over 1. So I go up 3 over 1, up 3 over 1. And this is our line. That's the first line. And now here we have a y-intercept of 1. And here slope is negative 1 over 3, which means we go down 1 and across 3. So down 1 across 3, down 1 across 3, and so on. So I'll actually write that in blue. I'll draw it in blue. And these lines definitely look perpendicular, and they are. I'm just telling you they are. But what can we tell, or what's the relationship between their slopes that tells us these lines are perpendicular? Well, the first slope is m equals 3. The second slope is m equals negative 1/3. What's the relationship between these two? One is 3, one is negative 1/3. Well, it turns out that these are what's called negative. They're negatives of each other, but they're not only that, they're negative reciprocals. Negative reciprocals of each other. And so, reciprocals. Which means that if one is 3, we take the negative of 3 and then we flip it. To reciprocate means to flip it. So, we go to negative 3 and then we flip it. If you flip 3 or negative 3, you get negative 1/3. Okay? So, let's just talk about reciprocals really quickly. The reciprocal of 2 is 1/2. The reciprocal of 2/3 is 3 over 2, and so on. So if we have an m of 1/2, then a slope of a line that is perpendicular will have a slope of -2, or -2 over 1. You see that? And so these two lines have slopes that are negative reciprocals of each other, 3 and -1/3. So you know that when you graph them, they're going to be perpendicular. They're going to have this right angle. Great, so now let's summarize. We went over properties of lines. We went over that lines can be parallel and they can be perpendicular. Okay, great. So these are the two main ways that we're going to analyze lines. Parallel means a same slope, that they have the same slope, and you know how to find slope. And perpendicular means slopes are negative reciprocals of each other. Okay, so if one is 5, then the other one would be -1 over 5. So those are the two ways we're analyzing lines. And in our next video, we'll go over some problems. All right, let's go over the problems for the slope topic. Okay, so you need to figure out whether these two lines for A, B, and C are parallel or perpendicular. Okay, so the A is y equals 3x minus 10 and y equals -1 over 3x plus 40. Are they parallel or perpendicular? The next, for B, y equals 1 over 5x plus 3 and 5y equals x plus 15. C, y equals 2 and x equals 3. So why don't you pause, take a few minutes, and do these problems. Alright, so for part A, well, we can see that they both have different slopes, but the slope for the first line is 3. The slope for the second line is the negative reciprocal of 3, or -1/3. So these guys are perpendicular. These lines are perpendicular, and that means that they intersect at a 90-degree angle. Let's check B. One slope is 1/5, and the other slope is, oh wait, we need to put it in the form y equals mx plus b. So the form is y equals mx plus b. So to get that, we need to solve for y. So I'll divide by 5, so that we get y equals 1/5 x, because x divided by 5 is 1/5 x, plus 15 divided by 5 is 3. Now, what about these two lines? Do they have the same slope? 1/5? 1/5, yes. So that means that they are parallel since they have the same slope. So in this case, you just have to change this form into the general form of a line, which is y equals mx plus b. Now for the last one, we have x equals 2 and, y equals 2 and x equals 3. For this one, you're not really going to use a y equals mx plus b method. You just need to realize that if you ever have a line where the equation is just y equals a constant or x equals a constant, that means it's going to be either parallel or parallel to the y-axis or parallel to the x-axis. So what do I mean? Let's check y equals 2. Y equals 2, well, that would be this point here. That's where y equals 2. So y equals 2 there. But also y equals 2 here, and here, and here. So, and here, and here, and here, and here. So the line y equals 2 is this horizontal line. So this is the line y equals 2. Now, so that line is horizontal, purely horizontal, and this is what I meant, it's parallel to the x-axis. Now let's look at the line x equals 3. Well, x equals 3 is here, x equals 3. But also x equals 3 is here, and here, and here, and here, and here, and here, and here. So the line x equals 3 is a purely vertical line. So this is x equals 3. And that line is parallel to the y-axis. So this y equals 2 is parallel to the x-axis. X equals 3 is parallel to the y-axis. Now what about the two lines itself? They're perpendicular. One is purely vertical, the other is purely horizontal. Of course, they are perpendicular. So for these types of problems where they just equal a constant, they're always perpendicular. Y equals 10, x equals 15,000, perpendicular, and so on. So these two lines are right as perpendicular, and that is the answer. Hey, great job, guys.
Thanks for watching the video. please be sure to check out our book on Amazon. It's a specialized high school test prep book. This book comes with 5 full-length exams with answer explanations along with a manual to go ahead and better prepare you for the exam. You will find the link on the video or in the description above. Have fun studying!